Hey, aspiring cloud architects, have you ever wanted to build your own private, totally secure corner of the cloud? Well, you are in exactly the right place. Today, we're going to roll up our sleeves and design our very first virtual private cloud, or VPC, right from scratch. Let's get to it. So think about it like this. The public cloud, it's kind of like a huge bustling city, right? Anyone can wander around. So how in the world do you build a secure corporate headquarters right in the middle of all that chaos? You don't just, rent a random room. No way. You have to architect an entire building with strong walls, with controlled entrances, and with private, secure offices. And that is exactly what we're going to do today, just with data instead of bricks and mortar. Here's the blueprint for our quick tour. First up, we're going to claim our own private corner. Then we'll dive into designing the internal layout. After that, we'll figure out how to safely open some doors to the outside world. And finally, we'll take a quick look at how these plans translate to the other big cloud platforms out there. Okay, let's put on our hard hats. Every great building, of course, starts with a solid foundation. And for us, in the cloud, that foundation is called the VPC. It's time to get our plot of land secured. So, what is a VPC, officially speaking? Well, it's your very own logically isolated section of the AWS cloud. Now, the two keywords there are isolated and you define. This is your private bubble. It's a space where you and only you control all the rules. Look, if the technical jargon is a bit much, just think of a VPC as your private plot of land in the cloud. Simple as that. You've bought the space, and now you get to build the fences and decide exactly where the front gate goes. You are in complete control of the perimeter. All right, so we've got our plot. But we can't just throw everything into one giant open room, right? That would be chaos. We need to actually design the interior. So it's time to draw up the floor plan using things called subnets and route tables. So how do we divide up this space? Well, our main tool for this job is the subnet. A subnet is really just a smaller section of your VPC's network. In our building analogy, you can think of subnets as the individual rooms, or maybe even entire floors, and each one can have a totally different purpose and its own set of security rules. And these rooms really come in two main flavors. You've got a public subnet, which is like the main lobby of our building. It's designed to be accessible from the internet. Then you have a private subnet, and this is like a secure internal office with no direct door to the outside world. This is where we keep our really sensitive stuff safe and sound. Okay, so if subnets are the rooms, how does all the data know how to get from one room to another? Or how to get out of the building completely? Well, that's the job of the route table. It's literally the building directory. It has a set of rules that tells traffic, hey, if you're looking for the internet, go this way. If you're looking for that other office, go that way. All right, we've built our isolated headquarters, we've got a lobby and some secure offices. But let's be honest, a building with no doors is pretty useless, isn't it? We need to add some very carefully controlled entry and exit points. And in the cloud, we do that with something called gateways. So let's start with our public lobby. How do we actually connect it to the internet? It's a pretty straightforward two-step process. First, we create and attach what's called an internet gateway. Just think of this as the main revolving door to our entire building. And second, we update the lobby's building directory, its route table, to say that the main exit is through that brand new internet gateway. That's it. Okay, but wait a minute. This brings up a really critical question. What about your secure back offices? The ones in the private subnets. They still need to download security patches and software updates from the internet. But we just said they have no direct path out. So how do we solve this puzzle without just throwing the doors open to an attack? The solution is actually really elegant. It's called a NAT gateway. A NAT gateway is basically like a super secure one-way shipping dock for our building. Our internal staff can send requests out to the world, and the packages they ask for come back. But some random delivery driver from the outside can't just waltz in for that shipping dock uninvited. It's outbound only, which is absolutely perfect for security. Okay, let's pull all these pieces together and sketch out our final blueprint. Part 1 is the basic layout. First, we create our main building. That's the VPC. Then, inside that building, we partition the space into our rooms. One public subnet to act as the lobby, and two private subnets to act as our secure offices. Part 2, public access. Now we installed the main entrance. That's our internet gateway. And then we update the lobby's route table to direct all internet-bound traffic right through it. Boom, our front door is now open for business. And finally, part 3, private access. We build our secure shipping dock, the NAT gateway, and we place it in the public subnet where it has internet access. Then we just tell the route tables for our private offices to point all their outbound traffic through that secure one-way door. And we're all set. Now, at this point, you might be thinking, okay, this is all great for AWS, but what about Azure or Google Cloud? Well, here's the really good news. If you understand these concepts, you understand the fundamentals of cloud networking pretty much everywhere. Seriously, the names might change a little bit, but the core ideas don't. And as you can see here, the core concepts are totally universal. What AWS calls a VPC, Azure calls a VNet. The idea of a subnet is almost identical across the board. And that NAT gateway for secure outbound access, yeah, it exists everywhere, just maybe with a slightly different name like CloudNAT. The architectural pattern itself is the key thing to remember. And just like that, you've actually done it. You've gone from a completely blank slate to a complete architectural blueprint for a secure, functional cloud network. You have your plot of land, you have your rooms, and you have secure doors to the outside world. So congratulations. But that does leave us with one final and pretty crucial thought. We've designed the building, the hallways, and all the doors, but who gets the keys to those doors? And what are the security rules for what people can actually do inside each room? Well, that's the next layer of security on our blueprints, and that's a topic for another day.